Okay, so last lesson we looked at, this is what I wanted to show you guys last lesson, but I couldn't show you. So last lesson we looked at equations, or we looked at a scenario of renting videos from Netflix. What else? Redbox and Apple TV. Yeah, and this is the graph that I created. We found several things. Number one is that what was super expensive?
Apple TV.
Apple TV, because what was so expensive?
Everything.
Everything.
It cost $100.
So that cost $100. What else?
It was $5 a movie.
So the rate of change was $5 a movie. Yep. And then, as Kane said, that Netflix is just a better deal straight across because you can watch movies and TV, but we were really looking at movies. But what we didn't get to see a great deal of was this is Redbox. So up until this point, which I think we said was about 7.5 movies, but nobody really rents 7.5 movies. What's the better deal? Redbox, right? So if you're only going to watch 7 movies over a month period, it's probably cheaper just to go get Redbox, right? But if you're a movie-holic, a TV-holic, what is probably the best deal after 7 movies? Netflix. Because, and I can figure this out because of this point right there where it intersects. Raise your hand if you can tell me, or you can remember what those things are called.
I have a question.
Yeah.
On this.
Yes, certainly.
So you said we did go over how if we watched about 7.5 movies, then we should go with Redbox.
Yeah.
Are we also adding like the amount of gas money we're also putting onto it?
Yeah. So I think this was the pre.
Or we can add all of that, or we can keep on going back and forth.
Explain that part again. Going back and forth.
If you go to the Redbox, you get one movie, and then go back to home, watch it, go back to another.
Yep, we're still factoring that in.
50 cents each time when probably end up Netflix.
Yeah. So Ken, that's a good question because this one was the original one. That was before we added all of the extra stuff in. So if you look up here, Ken, I'm gonna try to move it so you can see a little bit more. We still know that Apple TV was way up there. Why did we start at 100?
Because that's what it's on.
Yeah, because you have to buy that box initially. Let me erase my little circle where I can move it. Is that we still found, Kane, that even when we add in the price for gas and even the wireless adapter or the DVD, that point of intersection is about here. So once we add those external factors into it, it ends up being about 5 movies. And what is the cost that they would share at that point?
50?
Yeah, or 49-ish, yeah, because that's how much it would cost for Netflix. So back to my original question though, what are these things called? Remember, I said it once or twice. And they intersect. Yep, that's the point of intersection. What was that? Yeah, systems of equations or simultaneous equations. They're equations that are graphed at the same time and they intersect somewhere, and their points tell us something about the data, right? So the point here, let's do 549. 549 would tell us that at 5 movies, $49. So that's the point of intersection. That's the point where they would cost the same. Okay? So that's sort of like what we did for homework. So if you want to take your homework out, does anyone want to put their homework under the document camera so we can show some of the graphs? Goldie, you want to do that?
I mean, yeah, but I didn't get a point where they met.
All right, well, let's put it up there and let's take a look at it and see. I'm going to close the door. Okay, so Goldie, what was your equation? Can you slide it over so we can see your equation? Can you slide the paper over? Did you write an equation? Oh, I like how you used hearts.
Yeah, I could not tell the difference.
But they do intersect.
No. It's right there, and that's right there on 33. No.
It's
Because
ish,
it
right?
goes by 25, like cents.
Right, yeah, so you didn't use your scale where maybe I did mine, and I think somebody else did theirs where they did kind of by 50 cents, so they started at 20, which remember you could have started at 20, but that's okay, your scale's just a little different. But can you pull it up a little bit so we can see your x-axis?
Oh.
It's okay. And your x-axis was minutes, so, and then scroll back down, I'm sorry. So at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13-ish minutes, the cost is the same. Did you guys get that?
Yes.
Yep. And then what would that cost be? How can we figure that out?
$32.
Okay, how'd you figure that out, Goldie?
Well, I guess up by 1.
Right, but how'd you figure that the cost was around $33? You said here was the point where they intersect, right?
Yeah.
Yep. So how did you know that was $33?
If you go over on the y-axis, it's 33.
Yeah, and the y-axis is our cost. Raise your hand if you, I know some of you got really confused about the graph. Raise your hand if this helps you see it a little bit better. Okay, so the graph was our end result. Maybe we should start with the what? How did you graph it? Like what helped you graph it, guys? Okay, some people use a table. Did anybody else write any? Yeah. So Goldie, can you slide yours over a little bit so we could see? Did you write an equation?
No.
Okay. Ashlyn, will you put yours up for me? But do you see, Goldie, where you had never? Do you see that's not true? Because they do intersect. All right.
The equation.
Yeah, will you explain it for me? Sorry.
For Terry's telephone, the equation would be y equals 0.25x plus 30, because 30 is the starting point, and 0.25 is how much you're going up by each minute. And for Carrie's connection, it would be y equals 1x plus 20, because 20 is your starting point, and 1 is how much dollars you're going up per minute.
Good. Raise your hand if your equations match what Ashlyn got. Okay, good. Now I see some like different graphs though. Do you see maybe where you messed up on your graphs? Because your graph should have eventually done what? Intersected. Very good. Margaret, is your table okay to show? Because you did a really good table.
Yeah, I guess.
Yeah, do you mind going over and showing it? Does the graph in the table, do the graphs in the table, do they take a lot of time?
No.
They don't take a lot of time to do, you don't think? Okay. All right, so Margaret started, she didn't really start at 0, but that's okay. What if you had started at 0 at this table, what would have been your y value? 30, good. And then she just counted up, and then where does this continue, Margaret? You just stopped here?
Yeah, well, I mean, I made a table, but it was kind of easy, like, to calculate here.
Okay, so tell me about your calculations in your head.
Went up by 25 cents.
Okay, it went up by 25 cents. And show me your one for Carrie. Did you do Carrie?
Yeah, but it's like...
It's not complete, it's okay. All right, good, and we noticed that our rate of change is what? 1. How many of you did a table that looks similar to this? Good, and then did you graph them, Margaret?
No.
Okay, that's all right, because we've already seen we've seen Goldie's graph, and Ashlyn, you graphed it as well. I just want to show you real quick my graph so you can kind of compare yours to mine, and then we're going to move on from homework. We're going to check the back really quick.
Why they get the back?
Yep. So the blue line is Carrie, and the red line is Terry. Does that make sense, guys?
Yeah.
Okay, and then, thank you, Zach, going up here with my orange that I did, I got about 13, around somewhere between 13 and 14 minutes, and $33. So looking at this graph, can we tell when is it better to choose, or which operating system is the best to choose from? Is Carrie's telephone or Terry's telephone the best to choose from?
Well, it depends on how much you talk.
Okay, exactly like we talked about yesterday. It depends on how much you talk. Ashlyn?
Well, until they intersect, Carrie's is cheaper.
Okay, until they intersect, Carrie's is cheaper. Do you guys agree with that? And then after they intersect, what's the best plan after that?
Terry's.
Which one?
The other one that's not Terry.
Why?
Because it's not as steep. It's only 25%.
It's only increasing at a rate of
25
cents. So that's pretty expensive. So if you like to talk a lot, you should probably go with who?
Terry.
Carrie. And then Terry, excuse me. But if you don't talk much at all, like my grandma who has a cell phone and she doesn't really know how to use it, she doesn't. And she has huge numbers on her phone so she can see. So what would be the best plan probably for my grandma? The Carrie. Yeah. Or none at all, yeah. All right, so now I want you guys to turn over to the back. And on the back, just to save time, I went ahead, here we didn't have a scenario, did we? We just had equations. And you all know how to graph the equations. What I didn't see though, is that these equations actually represent what? Thank you, Colton. They represent what?
Lines.
They represent lines, and a lot of you just made line segments, and you didn't extend your line. So for number 2, where did they intersect?
4, -3.
4, -3. Does anybody need to go over that one? No? We're good? I'm going to move back here so I don't have to keep walking back and forth. I saw that some people forgot about the negative slope, and then therefore it didn't, their line wasn't correct. All right, what about number 3? Any questions there? -1, -1? Okay. And quattro. Why is that no solution?
Because they're never gonna touch.
Parallel, so they're never going to touch.
Oh, good, Goldie. So the parallel, they're never going to touch. What do we notice about their slope?
They're the same slope.
Yeah, so the rate of change is the same. What if those lines have been on top of one another?
It would be the same.
Give me the equation.
No solution. No,
This is no solution.
Infinitely many solutions.
Why infinitely many?
Because they
They're both on the same thing, so they all
and
have
they
the same
keep going
solution.
on and on and on forever.
Yeah, so they keep going on and on forever, and plus they touch all of the same coordinates, correct? All right, and last but not least is number 5, and where do they meet?
2, 2.
2, 2. Yeah. Raise your hand if you got most of them right, all 4 of them back. But raise your hand if you still are a little bit confused. Good, I would be more than happy to help you guys today. So in a minute, what's going to happen? What do we notice about all of these equations here? Margaret.
They're all in slope intercept.
Yeah, they're already written in slope-intercept form, so you can tell the initial value, and you can also tell the what?
Y-intercept.
Which is the initial value? Yeah, but the slope and the rate of change, right? So today what we're going to do is we're going to work with some where you can't really see that straight away, and you're going to have to go far back into your head when you know how to manipulate equations to make it look like that. All right? So your first activity, we're going to do 2 today. And the first activity is at your group, you're going to partner up with one person. So you're going to partner A and partner B. And partner A is going to have my favorite colored salmon paper. And then partner A is going to have salmon, partner B is going to have yellow. And what you're going to do, you probably are going to need a separate sheet of paper, but don't pull that out until I say go. Okay, so partner A and partner B are going to have the exact same problems on different sides. So if you'll notice, number 1 here is on the right for B and on the left for A. You're going to work You're gonna graph it, you're gonna see what you get, and then you are going to see if they match up, and then you're gonna move on to the next one. The reason why I said you're gonna need extra paper is because there isn't much room to work on here. Is everybody good? So within your group, I'll let you figure out partner A and partner B. Yep. And back there, I'll give you guys 2 B's or an A or whatever. Okay? There's yours. And then you can get started. So go ahead and go and get out your separate sheet. You send these two over there. All right, here's an A and B, and then here's another A and B, and then you guys decide. Here's an A and B to the side, and then here's another A and B to the side. A and B to the side. A and B to the side. A and B. I'm assuming you too. Yes. Can you get out a separate sheet of paper, please, darlings? You know where to go get some. Good. Okay, I'm gonna make you A, and then I'm gonna make both of you B, since that way you're in the middle. All right, that means you three are gonna have to work together to make sure your timing's the same. Yep, do you, gosh, it's so hot in here. Do you guys have enough sheet paper? Because you're gonna need one. Oh, that was so nice. All right, and then once you have your partners, you can go. If you need any help, all you have to do is ask. What's wrong? Tired. Hey, Michelle, let me grab my pencil. Which is
You're gonna be yelling.
okay, so 6.
Oh, there's a bat.
Yep, good. And then,
Sorry.
oh, so you haven't done the second one yet.
So I just grab it and whenever it crosses, I find it and then put it in.
Yeah, exactly. Yep, so graph the second one.
Y-intercept
Does it go
six.
negative 2
This is
side
1, 1.
first? Or does it go
Well, the 2 is what?
Teachers, pardon the interruption. Power School is up and it's running slow, but you should be able to get your attendance done. If you could do that at this time, please. Thank you.
Hold on one sec. So, we're right, but you have negative 2 over 1,
Yeah.
right?
So I know it's gonna go
So is the 2, right, but is your 2, you're changing Y's or you're changing X's?
X.
Well, let's think about that. So when we have our table, like if I made a table of values, when we find our slope out of our table of values, 1, 2, 3, 4,
Oh yeah.
it's the change in what?
Y.
It's the change in Y. So which way would you go then on that graph?
Sideways, right? This way?
Well, this is along
Oh,
the...
Y is this way.
Negative
Gotcha.
6, 1.
Yes, ma'am.
Right.
Well, why don't you wait and see what is Cassie your partner?
Yes.
Why don't you wait and see what Cassie gets? But you're gonna put your solution, your coordinates where you think they match there, and then you're gonna wait and see what she gets.
Oh, okay.
Okay?
Thank you.
Okay. So let's look at this first equation, which is y equals x plus 6. How do you graph? Where do we start to graph?
I'm not good at graphing, Colin.
Yeah, but so you're right, it is the y-intercept, but is it along the x-axis or is it along the y-axis?
So you go on the right.
Yeah, so you go to 6,
Over 1.
and you make a point, right? And then what's your slope?
So it's 1.
Yep. So you would go, yep,
Negative 3.
yep. And then the whole time it's gonna go up 1 over 1. And then what about the other way? Could you extend those coordinates down this way?
No. I mean, yeah.
Yeah, you could. It would be,
Down 1
Di-
over 1.
yeah, and negative 1 left would give you negative 1 would give you end up with result in a positive, right? Does that make sense? So like if I go down 1 and then left 1, I went in a negative direction both times, in a negative and a negative.
Equal to positive.
Yeah. So you could continue on going and connect them. Okay? All right, so Kaylee, your partner? So you guys got that? All right, now you guys are both here.
Wait, no, I don't like how many.
Oh, well, let's use your, how did you get -3, negative, or how did you get -3, +3 then? You just copied Kaylee?
No.
Well, first off, what should we do here? Do you see what I'm doing? Making a what?
Line.
Yeah, making a line. And then here I'm going to, uh-oh, you must have done something messed up somewhere. Up 2 over 1, up 2 over 1, yeah. Hold on a second, you graphed that one wrong. So you went to 6. Oh, is this the line that you were working on?
I guess.
All right, 6. So that was your initial value. Oh, my bad, +6. Okay, so +6. And then what's the slope?
1.
So what does that mean? When I'm graphing, tell me what to do.
Up 1, over 1.
Yeah. Like that? Could I continue it that in the other quadrant? How?
Down 1, over 1.
Mm-hmm. Down 1, over 1. Okay, and then I can connect them and make them a straight line.
So like, but
And then where do they meet? Where do they intersect? At what point? Did you say right there?
-2, 4.
Four. All right, so that's not what Kaylee got. So maybe let's check the slope of this one. Ah, I see. Because what do you see wrong with this one so far? Because that's this line right here. Well, where would you start to graph this?
Negative.
All right, I want you to fix it and then see. Yeah, you fix it and then see what happens. Okay? Yes, ma'am.
Sorry, could you check my work really fast? Because I don't think I'm getting the right answer for this one.
So the purpose of this is for you to get the right answer or get what your answer is first, and then compare it to
Partners.
yeah your partner.
Okay.
Okay.
Thank you.
You are very welcome. Hold on one sec. Hey, did you bring your form? Okay. So why don't you go to the computer lab? Go hang out there for a little bit. And if Miss Long asks, hold on.
oh, but it's -1 equals 5x plus 5, so then you divide it by negative.
Wait, what?
Yeah.
Well, my question is,
How do you graph it?
I mean, I'm pretty sure I graphed them right.
Okay, so let me see. We're gonna erase this. Well, Cody, why don't you help him then?
I tried.
Okay.
It's for you.
Okay. So let's look at this one. Where do we start to graph that?
For this one, what did you get for this?
What is the? So you've already noticed that the slope is 1, right? Where do you start to graph? Do you start with the slope?
You graph that and then you usually do that one. And
Is there such thing as a $50 bill?
the others.
I wear it like this. I'm so random.
No, there is?
Okay, and then we do the same thing for that one.
Yeah.
So we just try to get y by itself.
It's like a regular equation.
I want $100, but she was gonna give me 80.
How did you get this?
But you had to divide by -1.
This one is negative.
I don't get that.
Well, yeah, down and then, yeah. All right, so then use your edge of your paper and make a line for me. Like you want to connect them to make a line. You don't have to draw all the points. You could just connect it and make a line.
Oh, this is gonna take forever.
All right. Now let's do the next one. So the next one, where does it tell you?
-3.
Yeah, so go down to -3.
So, -2.
So if your slope is -2, that's a whole number, right? So what? 2 is your change in what?
Wait, what did you get yours to?
And then what would be your change in, no, not your change in x, I'm sorry, it'd be your change in, yep. And then what would be your change in x's? Not -3.
Oh, wait.
Why are your dots so small?
Yeah, 1, right? Because -2/1 reduces to just what?
It was 1/2.
So we need to graph that. How?
It's y over x.
Change it, you just told me you're changing it.
Of 1/2.
Yep.
Down over 2.
Yes. Good.
That's
Yep.
stupid.
Yep. Guys, don't get too far away from Kane, okay? And then if we want to extend it up this way, what could we do? Yeah, so we could go positive 2 in the y, right? And then left. Why does that work? I'm going up, but that's a positive direction. But then I went, yeah. Got it? All right. That's good? No. All right. You didn't come to a consensus on the first one? Yeah, you did. Okay, that's the first one. So now we're on the second one. You can't do it?
Nope.
I don't believe that.
No, you can't do it. You can help, and then you can't do it.
I disagree, friend. Look what you got there.
Yeah.
What is that form?
I just changed all to plus.
Yeah. And you made it into what form? Tell 'em.
You can tell. Lean really close into the mic.
What is it? Is it in graphing form? Can you graph it?
No.
You can't graph it from that?
No.
It doesn't have a slope?
Plus 5.
Plus 5? So that would mean you're changing y.
Plus 5.
And then what would your, what you call it be?
My y.
Your y-intercept is what? Yeah, so can you graph it from there?
Yes.
Perfect. All right, now let's look here. Austin, do you have your work?
I don't
Yeah, look, so let's compare your work with
know
Austin's.
what I did.
All right, well, Austin talked to, I don't need to tell him, you tell him. What did you
I need
do?
help on this one.
Right, look, he has it. Let's talk about it together.
I don't know if I have mine right now.
Well, let's figure it out together. So, Austin, what did you do first?
I did the equation and tried to get everything separate.
No, we're talking about this one, because we got that one right.
Okay, so I did everything like normally, and then I got here.
Cosmo, you listen? So he subtracted the 3x just like you did.
I think I did this one right. I don't know about this one.
All right, so hold on a second. So we're here. You both got to that point at the same time, except for...
How you're getting to it. Like, I understand.
Why?
No, hold on a second. Hold on. Let's get there.
Did you get
All right, can I erase this? Let's go back to what an equation, a linear equation looks like. And just that rough form without any numbers, all variables. What does it look like? Right, that's what it looks like on the graph. What does it look like in an equation? Yep. So we can't graph it in this form, can we?
But you did get positive.
No, we have to make it look like this. All right, so let's look at what we've done, right? So now we have our y, but the 6 is, we still have this -6 attached to it, or multiplying by -6. We just wrote ours a little backwards because you still both have positive 24 and you both have -3x, right?
Yeah.
How do I get y by itself?
You divide
divide by -6, right? Because -6 divided by -6 leaves us with what?
6, 0.
No,
Nothing.
1y,
Nothing.
which is what?
Because
6 divided by 6 is not 0.
it's 1.
Now, if we divide by 6, so Austin, what did you, I see what you did. You only divided by that one. What are you supposed to do?
I got it intercepts -2, -5.
Yeah, you're supposed to divide by the entire thing. So divide by 6. So fix it, and then I'm going to come back and look at it. Don't graph it, I just want to come back and look. Margaret, I saw your hand up earlier.
Wait, I did that
Did you figure it out?
though. That's what I did. We'll do it again.
Oh, I'm sorry. It made me faster. All right. Oh, I'm sorry. He had it.
Number 2.
Yep.
I don't think you're not gonna get a point.
What'd Zach get?
I'm lost on that one. I got 0, -4.
Okay. So when you changed them to slope-intercept form, what did you get for the first equation?
So what?
Do you have your work? You just did it in your head? Hold on, Tyra. I'll be right there. Or Tyra, is there somebody, can you talk to Alex about, maybe you guys had the same problem? So the problem that I see here is that you just did it in your head. You didn't do anything. Because you can't just...
That's right though.
Are you sure?
Yeah.
All right, tell me.
Okay.
All right, what do I do?
Add y to the other side
Why would I do that?
because you need to get y by itself.
Okay. So I'm adding y to the other side.
And you add 5.
And then now I have this.
And you take that 5 and add it to that side.
Okay, so would you say that works? So is it okay with you if I write y on the left side? Mm-hmm. So y equals, my pencil won't work. Y, thank you, good old fashioned pencil. Y equals 5x plus 5. Is that what you got for the first equation? You're here.
I did something. I tried it.
Where's your final equation?
I didn't get one.
Well, then how did you graph it?
Did it in my head.
No, this doing your head stuff does not work.
But I was right.
Well, yeah, you were right. Zach wasn't.
Yeah, but that's why
So
we
it works
compare.
50% of the time.
Exactly. So one of us is gonna get it.
We don't play that. Nope. All right, so then you graphed it. Let's see. Which line is this equation?
This one.
So 5, and then 1, 2, 3, 4, 5 over 1. 1, 2, 3, 4, 5 over 1. Good. All right, now let's look at this one. What did you do? I already see what you did wrong. Go ahead.
Okay.
Tell me.
So I added 6 to that side, and it would be 6y,
Okay.
and it would be
Can I write on this paper?
yeah
So you added,
6y.
I may write the original equation, Zach. Watch.
Yes.
All right, so tell me what he did. He added 6y to the other side. He added 6y to the other side, and then had 3x equals 24 plus 6y.
Then I subtracted 24.
Okay, subtract 24, subtract 24, and then what?
And then I divided by 6. The 24 because the 3x already has a variable, so you can't.
Wait, I'm sorry. So I don't know. I'm just weird. I like it like this.
Okay.
Is that okay? All right, now what?
Divide by 6. You get
Where?
24.
on the other side.
Just the 24?
No, you can do the 3. It's 3 over 6.
But it's
Crap.
3. It's 3x though.
It doesn't matter.
Right, so
It's 3 over 6x. It's 3 over 6x.
why do you divide by 6 on both sides? I mean, to both parts of the...
Because when you do something to that, you gotta do it to everyone.
Yep, so what he's saying is because you divided by 6 here, you're not just dividing by 6 to one of the terms, you're dividing by the entire side. So then this becomes 3 over 6x minus 24 over 6, which we know that we can reduce this to
You can reduce that to 1/2.
1/2 x.
Bam.
You're still wrong.
Well, I think you were both. I'm not gonna lie, you both are
I
wrong.
never got that far.
right.
Be talking.
So
Alright,
now
just
that
6 3 over 6.
well, look now that we have come to a consensus about the equations, right? Can we regraph them to see if they do have a point of intersection? All right, go.
Miss Van.
All right. I know. Is there not anyone else at your table that can help you? Y'all are all stuck on the same one?
No, they get it, but they can't explain it.
Oh, I think they should try again.
When it's -3, does it just go horizontal?
So, well, where would x be -3? So show me where x is -3. That's y is -3 because that's on the y-axis.
Oh yeah, well it would be right here.
Yep.
So would I just go here?
Yep. And then how would you draw that? How would you make that line?
I'd keep going.
Yep, because here x is -3. All along there, x is -3. No matter what y coordinate you choose, what's your x?
-3.
-3. Okay. Let me see if this is 5x minus y equals -3. All right, so when you added 5 over here, that actually left you with 0 on this side. And what did you add 5 to?
-5.
When you added 5 on the other side, what did you add 5 to? All right, let's start from the beginning. 5x. And use your pencil. 5x minus y is equal to -5. Michelle, can you help me out with this one?
Which one?
We are on number 2 on the second equation.
Right.
So he's on the first equation.
Okay. So, well, I put y over here first on the
Oh,
other
yeah,
side.
so y is kind of there already.
Yeah.
But how do we get it by itself? Because we want to make it look like,
You do the opposite, so you divide by -1. Because it's
well, but y is not by itself yet.
yeah. Well,
So what do we need to do?
I put it by itself before.
How? You can't just put it by itself. You can't just, you just can't, you just can't put the 5x on the other side, right? What do you have to do? Because they're like
Do the
log.
opposite and what's this?
Well, what would I do?
Divide by 5.
Divide by 5?
Divide by 5x.
Good. We would subtract because we want to move the entire 5x over to the other side. So we're left with on this -y is equal to -5 minus 5x. See what your difference is? You just took 5x and put it on the other side. Can you do that?
No.
Why? That's not right. With the equations, it's not right.
But is this right?
Well, obviously not, because something's going to be.
So that
See, now you ended up with a negative slope, but watch what happens here. Because do we have y by itself now? We do?
No.
No. What do we need to do now?
Subtract 5x.
Nope. Now we divide by -1, but we divide the entire side by -1. So now we have y is equal to, what's -5 divided by -1?
I think so. I don't know.
-5 divided by -1. You do know. What's 5 divided by 1?
Like 1, I think.
Michelle, will you help them out, please? 5. I think you and I have to meet on a separate occasion if we don't remember our division. Now I have -5 divided by -1, or -5x divided by -1 is what? Positive 5x. So this is the actual equation. Is that what?
Have we learned this before?
Yeah, we've learned like.
I forgot because whenever I used to do that, whenever I switched to the other side, I'd make it opposite. So I forgot to do
Yeah, we did this when we were like manipulating equations and solving for y. Miss Tanner was here when we did this. Okay, so now this is our equation number 1. let's look at equation number 2. So Michelle, change that one on your graph. And I'm gonna help you out with this one, bless you. And then I'm gonna go over to that table. Hey, Bridge, can y'all move on to another problem? Good, smart, that was smart.
All those back.
Yep. All right.
Wait, what is it? How do you graph X over 3?
All right, what do? I want it to look like this, because this is how I graph it, right? Can you graph it in this form? No, so what do? Perfect. And then subtract 3x. Can you subtract 3x from that?
Yeah.
From 24?
Yeah, it'll just be that number for the X.
No, why can't you subtract 3x from 24? Michelle, why can't you subtract 3x from 24?
Because they're different. Like this one's a whole number, this one has an x, like a is it a variable?
Remember, they're not similar terms because this doesn't have an x. So now what would I do? I'm trying to get the y by itself.
Oh wait. Yeah, that's not negative. Okay.
By. Good. And negative 6 divided by negative 6 is?
No.
Negative.
1. Yep, which leaves us with 1y. Now I divide by negative 6. And what happens?
No, it's negative 2, 1. Excuse me.
Remember, we divide it by everything. So 24 divided by negative 6 is?
No, it's not.
Yeah, it is.
X equals negative 3. Why would
Go ahead, ask.
Why wouldn't you just do like 24 subtract? That's 1 over 1.
Because you can't, because this is a whole number. This is saying 3 times some number. We don't know what that number is. So we can't subtract them because we don't know what this number is. If it was 24x minus 3x, then you could subtract them. Okay, so 24 divided by negative 6 is?
Negative 3 is
negative 4. Yep, and then what?
X is on the other side.
Negative divided by negative 6, which is?
What does it say?
There is no y.
Well, 6 divided by 3 is 2.
There is no y. There is no y.
1/2 x.
It's red.
I'll be there in a sec. So now these are your 2 equations. I want you to try to graph them for me, okay? All right, Michelle, don't move so fast. Let's let Corey get caught up. Hold on. I know. That's right, you did have a hand up earlier. I'll be back.
We're after.
All right, so is that the one you both are on?
I'm confused just how to do these. I don't know how to do them.
Okay, so let's talk about this together. Can we graph it from this? Can we graph that?
No.
I can't graph it. What does a linear equation need to look like in order to graph it?
It doesn't equal anything? I don't know.
No, what's a linear model? Like, what are the linear models we've been working with for like weeks and months now?
I don't remember what. Never mind.
Okay, well, all right, let's go back to the previous problem. How were you able to graph this?
Looked at the problem and then graphed it.
Okay, so what could you find in that problem that helped you graph it?
Y and slope.
Right, so what form is this equation in? Yeah, isn't that our linear model that helps us graph? Which is what? Like, what's the generic way to say it? Y equals? mx plus b. Okay, are you tired?
Yeah.
Okay, I need you to pep it up for me because we got a lot more to do. All right. So, does this look like that?
No.
How do we make it look like that? Did you do any work to change it? Does that make sense, Connor? That we need to make these equations look like this before we can graph it?
Yeah, I guess so. What does the M stand for? Is that just slope?
Mm-hmm. And then what does B stand for? Well, you knew here because you graphed it.
Isn't it a y-intercept?
Good, it is the y-intercept, right? So I want you two, I'm going to leave you for a minute. I want you two to work together, and I want you to change this first equation. Are you guys partners? Okay, we'll be partners for this problem. I want you two to work together to change this first equation to look like slope-intercept form. And if you need to grab these guys and get some help from them, do that, okay? The point is that you're working together. I don't want any of you on your own. I want you working together to help each other out, okay? I know. Popular person today. All right, which one?
All of the
Is everybody on 3?
No, I'm on.
They-
He's on 8.
They get it, but like,
And I appreciate you, Logan, leaving your teammates. It's great.
No, he was trying to explain it, but he can't
This is
really.
my teammate.
Well, your whole table, you guys can work
well, yeah,
together.
we still, he like tried to
we
explain it. And he's like,
All
I
right.
don't know what I'm doing. I just know that I'm getting it right. I'm like, oh,
Well, good. He thinks he's getting it right?
Yeah.
All right, so Colton, where's your paper that you're doing?
Wait, I'm still.
Right, but where are you guys are just working together to do this?
Yeah.
All right, so here's 3. You start with 2x, subtract 2x. Yep,
I kind of did a little.
yep. Yep, that's right.
okay.
So what's your question?
But our graphs, like all of our
Don't turn out
graphs,
right.
end up.
All right,
They
so
end up
let's look at this. Oh, I see what you did here. Colton, look at this. What did she do here? So she subtracted x, and then she subtracted x from.
It's a negative 1x, Bridget. I didn't look at your equation.
See, well, that would help. That would be helpful, Colton, if you guys looked at each other's work instead of just the graph. Okay? So now try to fix it.
I don't get how to do the equation.
So it'd be.
Okay, so I'm gonna go back to the very first one. Were you able to graph the very first one?
Yeah.
Were you able to graph the very first one?
Yes,
Okay, and why were you able to graph it?
because it had equations to tell you how to graph it.
It had equations to tell you how to graph. Do you agree?
Yeah.
And what about those equations helped you graph it?
They had the slope and the y-intercept. So
Do you agree? Okay, and then,
do it
hold a second, does this have a slope or a y-intercept that you can identify straight away?
Yeah. And then you just go down one.
I don't know.
One.
Does it? I mean, can you look at it and tell, does it look similar to that? No, so how do we make it look similar to that?
You have to get a y on the inside, but I don't get how to do that.
Okay, so let's walk through it. Which number are you on now?
Yeah, what's that?
Let's just start with the one that you're on. All right, and you're working on the second
-4.
equation?
Yeah, I did that.
Okay.
-4.
Yeah.
All right, so I'm gonna rewrite it. X minus 3y. Logan, here's where I want you to help me out. Okay, look at what she did first. She added 3y. But you just told me that you needed to get the y
No.
by itself. The y needs to be by itself, right?
yeah,
They're negative.
Why would you add 3y if she just told me you wanted to get it by yourself?
So you get it by, you have to get it to its own side to get it by itself, and you have to divide.
Would you like that? Look, like that?
Yeah, they'll just keep going
It
like
can't be
that.
on the
So
same
what do we
side
write?
as everything else.
Okay, so then why would you move it over here with 24?
Because you
It's already with 20, you want it by itself. So which term do we need to move? Yeah, how would we move the x?
no subtract it
Why?
because it's positive.
Did that make sense?
It says it's positive.
Since you know how to do the equation.
Why?
I'm kind of just gonna do one of them. Simple one, then you do the other one.
But what I'm saying is, why do I
Number 4.
subtract? It is the what?
It's
There's no y.
What's
So it's just a
not
straight
the
line.
opposite? It's
Starts
the.
at -3. It's just a straight line. This way.
It is the opposite operation, right? And you're right. But what's the right word? What's the correct word for that?
coefficient.
No, it's the inverse. Remember, it's the inverse operation. So we're subtracting x. We're subtracting x. Can you subtract x from these two?
No,
Why not?
because it's like an x and that's a number.
That's a whole number. Okay, so I'm going to rewrite it. Cool. Logan, you with me? I'm going to rewrite it. Are we almost there to get x or y by itself? What would I do?
Divide by 2. No, I know.
divide by negative 3.
How do we do that?
Because it's the what?
There's no y.
Holy crap. They're not plus.
Inverse. And negative 3 divided by negative 3
There's
is
no negative. And then there's no y.
1,
So you
which
start at
leaves us with
-3 and then
1 y.
It's just a straight line.
Now, if I divide by negative 3 on this side, I have to do what on the other side? Divide by negative 3. Thank you, Tia. So now what?
1/3 x.
How did he get 1/3 x? Because that's a
1.
Yep, and negative 1 divided by negative 3 would be
1/3.
positive 1/3 x. And then we do it here, which would be what?
-3, -3.
8. Yeah.
Yep. So now could you graph it in that form?
Yeah.
Yeah, so that's all you're doing. You have to be able to get these equations to be able to graph them. You have to transform them.
You got -3. It doesn't show how far it would. I already did one of the lines.
Are you sure? I think you graphed something wrong.
X is negative.
So x is -3, but this is that -3 that you just put there is on the.
Is this supposed to be?
Yeah. Yep. All right, I gotta go them because they had their hands up first, and then I'll come back to you guys. All right. Well, good. You're right. So what would the line look like for x? You're at the right point. So what would the line look like for x is -3? Yep. Yes. Why?
I really don't know. I need to have here. You can just
Because the y will always the x will.
I got what you got though.
So x is always going to be what?
So you got it right.
Good.
That's so hard to split.
No.
No, I'm sorry. I may have to change your partners.
We did. No, you said to do this one, and then you said to
We waited for you to come back almost with 2 for the longest time.
and then you just said like,
And you didn't think that maybe you were right and that you could move on?
But you should have told us that.
Or you didn't have these two lovely women over here that could give you a help?
we were only simply following directions that he gave us.
You were following my directions.
We already called our lifeline. We can't.
Who was your lifeline? And they didn't help you out? All right, so you were working on number 2 and you were working on the second equation? Where? No, wait. You were working on the first equation.
This equation.
This equation. Bob's your uncle, you got it right.
Is this one right?
Where's your work?
I need help with
This one
number
is
2
different
still.
on his.
All right, so here's what happened. Whenever, what's that, a 9?
Oh, no, that's not that. This is number 3.
Sorry. All right, so Cosmo, I want you to look at what Austin did compared to what you did.
This is
This is
the word for that.
It's almost the same. I just
It
have
is.
negative 5x and I have plus 5x.
why?
Because he told me to put it.
I did not tell
You
you.
said you were like
No,
age.
no.
Well, Austin, can you do me a favor? Can you explain to him why you got that? Because what we're talking about, if you see the difference between your work and his work, is that 5x.
Oh no, I forgot to divide the one by everything.
Yeah.
I didn't know that one.
So what I want you to do,
Did I do it right then? Am I good?
you still have something wrong. I want you guys to work together to figure it out. I want you to talk. Here, look, since you can follow directions very well, I want the two of you to work through this equation until your equation is exactly the same. Got it?
2 9.
Can we know what we did wrong?
Yeah, that's what.
Yeah. Whenever you figure it out, whenever you get the same equation.
This is not practical and will not be used in a real life scenario.
Actually, we proved that it would yesterday.
Yeah, if Jim wants 9 minutes.
I need to find out if Netflix is better than Apple TV rather than just looking at
Go. Work in the equation. Go.
Second one on the board.
problem.
Do the equation.
You got 30.
Okay, good. So you got the first one right. Let's look at this one. You have 2 minutes to get this right.
Okay.
All right, so x is -3. Where is x equal to -3?
-3.
Wait, which -3? I have two. I have this one and that one.
Okay, that one.
This one?
No, that one.
Well, that's on the...
Oh, yeah, that one.
Because it's on the what?
X-axis.
X-axis. And so is the line going to go this way, or is the line going to go that way?
That way.
Okay, so that would say that if we did the line this way, what would the coordinate at this point be?
Because
Why?
Because your X has to stay the same.
Your X has to stay the same. So if we were to look at this point, what would our coordinates be?
-3, -6.
-3, -6.
So what's the answer?
Thank you so much. And I understand that you don't get it. So,
I did this, and they were parallel. Colin said he didn't get that, so I thought it was.
okay, so show me where your work is to. I really appreciate the fact that you've obviously given up. It's great. I appreciate it. And it doesn't help me at all. It doesn't. It doesn't help me at all because you're just sitting here and you're not trying. You're not using Michelle. So what can I do to help you here? No, I can. I want to do something. I want to help you. I don't even know what number you're on. You're on number 2?
I'm doing it.
Okay, so I think that's the one that we worked on together, right?
Yeah, and I grabbed it and it came out parallel.
All right, so can you show me how you graphed it? Tara, I'll be there in just a second. Is there anyone else at your group that you can use to help?
When the 5, the intercept?
Yep.
It'll be 5, right?
Yep, and it's positive 5.
Over 5.
So it's here.
So you'll go over 5 and down 5?
Well, what's your slope?
5.
Yep, so 5 what? What's your change in Y's?
5.
What's your change in X?
5. 1.
Because 5 over 5 is 1. What did you just say?
1.
Yeah, because isn't 5 over 1 reduced to
1. No, 5.
5? Yep, so your change in your Y's is 5. Your change in your X is 1. Yeah, so let's graph that. Change in Y's, am I going to go left or right? Am I going to go horizontal or vertical there?
Right here.
To do the 5.
Vertical.
Yeah, because that's, so up 1, 2, 3, 4, 5. Oops, I shouldn't have put it. And then what?
Over.
1. Left 1?
Right.
Right 1, because they both need to be what? Positive. Yeah. All right, now if I want to extend it this way, I could go down 1, 2, 3, 4, 5 over 1. And why does that work if our slope's supposed to be positive? Because this way is what going down is, yep, and going left is.
So wait, am I going negative and positive 1?
Well, no, you just listen to what you just said. Left is positive or negative? Negative, and a negative over a negative is a positive. So yeah, so now I'm going to use the side of your paper.
That doesn't make sense though.
Yeah. Okay, what part doesn't make sense? What part don't you get? Tell me, you don't get the graphing part? Yeah. All right. So what I'm going to do is I'm going to give you these equations in y-intercept form, and then I want you to practice graphing, and then we'll tackle this bit tomorrow. Okay? Can I go ahead and do that? All right, let me do that. Yes. Okay, so what does slope-intercept form look like? Y equals mx plus b, so write that at the top of your paper. Can I see this for just a second? Okay, and then what number are you on? You're on number 2. So write number 2 there. Sorry, I just need to get the answers to this really quick. Y equals 2/3 x plus 4. Y equals negative x plus 9 Tara, all right, so let's work on this one first. What's the first thing that we need to do? Hey, are you guys finished? Because I do have more stuff.
I am almost done.
Good. Because it doesn't quite sound like it. Yep. I'll be right back. All right, Corey, I've given you the first in y-intercept, and let's see if you can graph them first, and then we'll tackle that other piece tomorrow. Okay. What we have? So does this look like this? What are the characteristics of this form that you notice that we need to make this look like?
The Y's in the front.
Okay, or not necessarily in the front, but it's what? By it's alone, right? So this equation is written in terms of y. It's written so that y is equal to all of this, right? And that's what we want to do to this equation. We want to make this equation in terms of y, so that y is all by itself. What would be your first step to do that?
Move the Y.
No, now look at this. Let's look at this. What would we do? Move the y over here? Would y be by itself, or would it be alone over there on the other side?
Would you subtract that?
Subtract what?
And then bring it over.
Okay. Would that get y by itself? So that's probably not an answer. What would the next thing? Show me which, if we're looking at this, show me which term is with y that should probably move.
The X.
Well, not just the x, but what?
The 5X.
Yeah, the 5x. So how do we make the 5x go to the other side of the equation? Yeah, we would subtract it. Why?
To get Y alone.
Right, but when I subtract 5x and 5x, what does that make?
0.
0, yeah. We do the inverse to make it 0. So then we subtract 5x. Now, can we do anything over here on the right side? I can't, can I? So, I'm going to rewrite my equation. And why did I bring down the negative sign in front of the y? And I'm going to do this. And now what?
Graph it.
Can you graph it? Because is the y alone? Is it in terms of y? No, right now we have it in terms of negative y. So how do I get rid of that negative?
You add.
Connor, can you help us out, please? What would we do? How would we get rid of that negative?
Where? That one right there?
Yep, no, right here.
Oh, right there?
Mm-hmm.
When you need a y on this side?
No, the y's on. We're almost there. We almost have y all by itself.
Wouldn't you do 1y and divide it or something?
Why would you divide it?
I don't know.
You're right, but why would you divide it?
To get rid of it?
Not to get rid of it, but to make a positive 1. So if we divide by negative 1, what's negative 1 divided by negative 1? 1. And doesn't that leave us with a positive 1y? Isn't that what we want? Yeah. So now we're going to divide by negative 1. And we have to divide the entire thing by negative 1, not just one term. So what would I do?
Divide that.
Yep, and what do you get?
5.
Okay, and then I need to do that, and what would I get?
5x.
Positive 5x, right? You're amazing. Have you checked with your partner? Okay. Now is this in a form that we recognize and know how to graph? Yeah. Okay. I want you to try this one by yourself, and I'm going to move over to someone else, and then I'm going to come right back. Okay? All right, guys, we only have about a few more minutes. I know, that's why I was coming this way. Are you all four together, consensus on everything? You did? Is this supposed to be parallel?
What is your answer?
Well, let's look at where's your work for that one?
I put
Number
this
7.
on the right spot.
So subtract 2x, divide by 9.
And negative
27 divided by 3. You get negative 2/9. Yep. And then this one, subtract x. Well, they would be parallel. They should be parallel only if they have the same what? Slope, right? But they don't. I think where you messed up. Look here. What do you notice about that slope?
Reduce it.
Well, you can't. Can you reduce 2/9?
No, you can't.
You can't reduce 2/9. But what do you notice about that slope? No.
3 goes up to 9.
No.
Oh, it's negative.
It's negative. And did you graph it negative?
They're both negative.
They're both negative?
Oh no, one's not negative.
Alright, so why don't you regraph this one and see what you get. Alright, well let's look. So you started at 3, and then you went down 2 over 1, 2, 3, 4, 5, 6, 7, 8,
Go to the intersection
9.
and that's what you graph.
Oh, good.
I know.
So just graph your second one. Alright, graph your last question, and then we're gonna wrap up here, peeps. Okay, so where does negative 3 go?
That's the y-intercept.
X is equal to negative 3.
Well, there's
Where
no y.
where does x equal negative 3 on the graph?
Negative 3.
Where?
On the x-axis.
On the x-axis, yeah. So where does x equal negative 3?
Right there.
Where? Show me. Put a point. Yeah. So x is equal to negative 3 here. Okay, now we have to make it a line.
So it's just
Where does x equal negative 3 all along that axis?
4.
Yeah. So if we were to draw this line here, what's the coordinate for this point?
Negative.
No. Negative 3, 2. So is x still negative 3? What about here?
negative 3, 3.
Yeah, so x is still what?
So our intercepts are negative 3, 4.
Okay. All right, so I could tell that we struggled a lot today. Some of us did, some of us didn't, because some of the equations I gave you were not what? No. Yeah, they weren't in a form where you know how to graph them. And what does that model look like?
Y equals mx plus b.
Where where m is your
slope
or your rate of and b is your initial value. Yeah, everybody's cool with this, right? I just want to make sure we all know this, right? But these crazy equations that I gave you, such as this one, we noticed that what? Yeah, they're not. Can you look at this and pick out the slope or pick out the y-intercept and graph it from there? No. So we have to manipulate this equation to make it look like...
Regular form. Standard.
No, we have to make it look like...
Oh, okay, I'm sorry.
Y-intercept form, right? Does someone want to come up really quickly and show me how to do this? All right, Margaret. And I need everybody who struggled with this problem, so this was number 3, to look at your work and compare it to Margaret's. We're on number 3 on the front. All right, and Margaret, tell me how you knew, bless you, to subtract the 2x.
Because you have to get the y by itself.
Yeah, you have to get, okay, good. And then knowing to subtract it. One more question, quick, I'm sorry. How did you know to subtract?
Because the positive, you have to do the opposite.
Or the inverse, very good, yeah. Oh, how did you know divide by negative 3? Well, you didn't show me on the other side. Sorry. Your y? You're going to divide the y as well? You mean you're going to move over -3y as well?
What?
You wrote y here.
Yeah, because that's what you said.
No, why? Why didn't that work?
Why?
Does it matter?
Yeah. Do you see the difference in what you had versus what I just did? Because -3 divided by -3 is 1y. Yeah. And then you divide the -3 by everything.
Yes.
Yep, good. All right, here's what I need to do. I don't want anybody to move. I'm going to show you a quick problem. And I would like us to quickly do this on our, just on a random sheet of paper, okay?
What are we going to do with this paper?
You're going to keep it.
Are we doing it for homework?
All right, you ready? Here's the problem. Here's the problem. You can just draw a sketch of it, and I want this to be for homework, please, so just quickly draw a sketch of it. You don't have to do all of the numbers exactly, just quickly draw a sketch, and you can do it on your work paper. And the question is, describe how many solutions there are and how you know the solutions are correct. I know it sounds super hard and super complicated, but in the grand scheme of things, it really isn't. So don't overcomplicate it. Just know it, take what you know about systems of equations to make it work.